Welcome to Spring LIB.
In this problem, we have been given that there is an elevator and a person having mass of 75 kilograms is in this elevator. So we need to determine the weight of this person when the elevator is at rest. So in that case, the weight will be mass times the acceleration due to gravity. So we take the value of acceleration due to gravity as 9.8 and we multiply that with 75 to get the weight as 735 newtons. And in the next two cases, we have to figure out the weight of this person in the elevator if the elevator is moving up and coming down at a constant speed of 3 meter per second. So as we know that if the speed is constant, the acceleration will be zero. And in the two cases, if we see the only force that's acting is the weight and the normal force on the person. And hence, the weight of the person in this case will be even 735 newtons. In the next case, we have been given that the elevator is accelerating upward at a rate of 3 meter per second square. And we have to determine the weight of the person in this case. So, observing the free body diagram once again, we can see that there is weight of the person, that's 735 newtons, and there will be normal force. So if we apply Newton's second law here, the net force will be n minus 735, and that will be mass times the acceleration, which is three times the value of the mass of this person, that's 75. So when we multiply 75 with 3, we get 225. And in this case, we can see that the normal force applied on the person will be equal to 960 newtons, and that's the weight that is read by the weighing scale kept in the elevator. In the next case, we see that the elevator is accelerating downwards at the same rate, and now we observe the free body diagram where the forces remains in the same direction, but now the direction of the net force changes, and hence 735 minus n will be equal to m into a. And from here, if we figure out the normal force comes out to be 50, let's just subtract 225 from 735. So we get in this case as 510 newtons. So that's the weight of the person in this case.